Okay. Yeah, this one's a little weird.
Okay.
Because I don't know if I can verbalize this one. This is like a picture thing.
Let me make you the
Here, let me.
presenter. Let me have a look.
Okay. All right, there we go. Can you see it?
Yes, now I can.
All right. Yeah, that's what it is. So it says determine whether the correspondence is a function.
Okay. What determines whether something is a function or not is that for a given value in the domain, you only have one value in the range. That's all that matters.
Okay.
Okay, so let's start with z.
See, that has two, so that isn't a function then, right?
Exactly, immediately. If it
So
was
no.
just f, y, and g, it would be a function, but z gives you two values.
Okay.
Therefore, it's not a function. Okay.
Okay.
Now,
Determine whether.
yeah, you don't see any identical numbers there anywhere, right?
No.
It's a function
Oh, so if there's no identical numbers, it's a function?
automatically.
Okay, cool.
What would not make it a function is if you had a 1 comma 4 and you also had a 1 comma 28. In other
Okay.
words, if for the same value of x you have two different values of y, it's not a function. However, the reverse is not true. You can have two different values of x and the same value of y. Part of the problem with switching presenters is I don't get to draw.
Yeah, that's the only
And
sad part.
it makes it a little difficult. It's tough for me to tutor math
Yeah,
without
you
being
can
able
take
to
it back.
write. Well, let's go ahead and answer this. Let's go to the next one. And as soon as we get one that we don't need you to be the presenter, I can switch back to being the presenter myself.
Okay.
Go ahead and answer
So,
that. Oh, the domain. What's the domain?
it's not like, hold on, I have it written here. So the domain or the range is up, right? And the domain is down. Is that correct? Or
Domain is the x.
the x? Oh.
So it's 1 comma 6 comma 7.
Oh, okay.
The
Okay, but just on
range,
the right.
the range is the y values.
All right. So would it be those three numbers?
I think so, yeah.
Okay, cool. The range is okay, 4 comma 24.
Mm-hmm.
So domain is x values.
Exactly.
All right,
Range
just
is
a
y.
second.
Go ahead and enter that and go to the next one. We'll see if it's something that
Given that g of x equals 2x squared minus
so
2x plus
let's go
7.
back. I'm going to make me the presenter.
Okay.
We can switch back and forth if we have to. Just
Yeah, it's not too hard.
requires quite a few click-throughs. Can you see my screen now?
Yes.
Read that function to me.
Okay. It's g of x.
Okay.
G of x equals 2x squared minus 2x plus 7.
The first question is g of 0.
Okay.
What is it? I forgot. I was trying to do it based on memory.
Okay. So the first question, yeah, it's and the end. Do you mean like the answers, like A, B, C, D? Oh, never mind.
What's what's inside the parentheses on the first question?
It says A is G of 0.
Okay, what is G of 0?
It's just 0, isn't it?
No? What this means is that whatever is inside the parentheses, you plug in for x.
Okay.
So the
So it'd
answer,
just be 2, 0 squared minus 2, 0.
one thing that happens when you plug in 0, it wipes
Just
out,
automatically makes it a 0.
automatically make both of those first two terms 0, and you're left with 7.
So x would just be plus, or x would just be 7, or
0
D.
is 7. Yeah, while
Okay.
you're doing that, let me fix up my, let's make sure that says G of x.
Um,
Okay.
the next one is G of negative 2.
Okay, what's that going to be?
It's going to be G of negative 2 equals.
Rather than trying to do that in one step,
Yeah,
let's do this. And then simplify. The reason is there's a lot of negative signs here.
mm-hmm.
And the worst thing you can do in algebra is drop a negative sign. Now simplify.
Okay, so
Times what?
that'd just be 2 times, that'd just be negative 4 squared
No.
is the first one.
Negative 2 squared, which is positive 4.
Okay.
That's
Yeah.
to get there. Now what is this?
Now that a negative times a negative, or a negative, yeah, times a negative is a positive.
Correct. So that's
So that would be just 4.
plus 7. So you have 8 plus 4 plus 7. I think that's 19.
Yeah. That's 19.
Go ahead and put it in and then let me know if we got the wrong answer.
Okay. That was correct. The next one is G of 2.
Hold on a second. I'm having a hard time erasing these. Wow. What is it with this program? The eraser doesn't work.
Of course, that's nice.
Well, I don't know. I just scroll down to get to a new page, but then I got to rewrite the function. 2x squared minus 2x plus 7.
I think I already got it. Let me check. Yeah, I already got that one.
Okay. What's the next one? G of
Okay. It's G of negative x. Okay, so
now,
plug that in. Would it just
if there's a variable inside that, whatever is in the parentheses, plug in for x in parentheses.
okay?
So tell me what to write here.
So we'd get 2 parentheses negative x squared, and then we get negative 2 parentheses negative x minus 7.
Okay. Do the exponential first.
Okay, so we just get 2x
Squared.
minus, 2x squared.
Negative x times negative x is x squared. Okay.
Negative x times negative x, okay.
Yeah, that's positive x.
All right, that makes sense. Okay, the next one is just, that'd be positive 2x, correct?
Uh-huh.
Minus 7.
That's the answer.
And yeah, okay. Let me write that down just a second.
If I remember, the last one said 1 minus t or t minus 1.
Yeah, it's t minus 1. Hold on, I'm writing this one down real quick.
Okay.
So it's plus 2x. Hold on, I'm just making sure this is all right.
Yeah, if at any point it doesn't like your answer, holler, and then we'll go back and figure out where we made our mistake.
I'm just checking to see. I think I might be wrong.
Mm,
Okay.
don't think so.
It says to find the indicated value of a function, substitute the given value of x into the equation and simplify, which is what we did, but
You didn't like the answer?
yeah.
Hold on, let me make you the presenter and let me take a look.
Okay.
Getting more used to switching back and forth here. It's not so tough once you get used to it. So we're looking at g of minus x.
Mm-hmm.
What did we come up with? We came up with 2x squared plus 2x minus plus 7. No, was it plus 7? It was plus 7.
Plus 7?
Yeah, in
Oh, that's
other words,
probably
that
why.
doesn't change, the plus 7.
Oh yeah, see, I made it a minus on accident.
Okay.
Oops.
I'm
All right.
going to go ahead and make myself the presenter again.
Okay.
Was it t minus 1 or 1 minus t? I think it was 1 minus t.
1 minus t.
Yeah, that's what I thought. Erases it, but with a time delay. It's really weird. So
It
1
is kind of
minus
strange.
t. Okay, so what are we going to do? 2 times
So
what?
we would get, there'd be 2 parentheses 1 minus t squared plus 2 parentheses 1 minus t plus 7.
Minus.
Yeah, minus 2 parentheses 1 minus t plus 7.
Minus 7.
Minus 7?
The original function was minus 7.
Okay.
Correct?
Oh. No, the original function is plus 7.
You're kidding.
Yeah, I think that's what we did wrong. That's why that one problem was wrong.
So the answer on that minus x should have been plus 7.
Yeah, that's why I got it wrong.
Okay. So I just copied it down wrong. So it's 2x squared minus 2x plus 7?
Yeah.
Okay. Now what we have to do is simplify that.
Okay.
What's the first
So
step
one
in simplifying it?
exponential, so
Okay.
1 doesn't square, so we just get 2t, or t squared.
First, do the exponential first. Remember the 2 is not being squared.
Oh yeah, I know that's not being squared.
So 1 minus 2. So we need to square that first.
Okay. Would we get 1 minus t squared? Or
No,
plus
1
t
minus
squared?
2t plus t squared. Here, let's go down here. 1 minus t times 1 minus t. That's what 1 minus t squared is.
Okay.
FOIL that. That times that is 1. That times that is minus t. That times that is minus another t. That times that is plus t squared. So we end up with 1 minus 2t plus t squared.
Okay.
That's what goes in that. And now distribute this second 2 and remove the parentheses.
Okay. So would we get negative 2 plus 2t?
Correct. Plus 7.
Yeah.
Now we just have to distribute this and simplify that. So now distribute the 2. What do you get?
Okay, so we get 2 minus 4t plus 2t squared
Keep going.
minus 2 plus 2t plus 7.
Now simplify that.
Okay.
So how many t squareds are there? Always start from the highest degree.
There's only 1 t squared.
Well, okay, there's 2 of them, but that's fine.
2 of them.
You're right, there's only 1 in that. So that takes care of that.
Problem.
How many t's do we have?
We have 1, 2. We have 2.
What's the net?
Wait, say what?
What's the net? When you combine them, what do you have?
Oh, we'd have negative 2t.
Huh? And now combine all the numbers.
Okay, hold on. Negative 2t. And then we'd have 5 plus 5. Or 9, I mean, sorry.
Plus 7 minus 2. The 2's cancel and you got plus 7.
Oh, yeah, I didn't notice that too. Okay. So the final answer is 2t squared minus 2t plus 7.
Yeah, go ahead and put that in. Let's make sure that we
Okay.
haven't made any mistakes.
Okay, yeah, that was good.
Okay, so what we've learned is that no matter what's inside the parentheses, even if it's a super complicated expression, just substitute it for the variable and
Okay.
then simplify. That's always
Awesome.
what you want to do. In other words, if I told you what is x minus 1 over x plus 1, then I'm substituting that for t, or for x, excuse me, everywhere.
Okay, cool.
It's as straightforward as that.
All right, nice.
Okay.
Okay, so the next one is g of x equals 5 minus y, or I mean, sorry, x minus 5.
Hold on.
Okay, x minus 5 over x plus 8.
Here. I've got to find a different program to do this.
Right.
This is terrible. I can't believe I'm still doing this. G of x is equal to what again?
X minus 5 over x plus 8.
Okay. And what do they want to know first? G of what?
G of 7. So that would just be G of 7 equals 7 minus 5 over 7 plus 8. So we get 2 over 15.
That's as simplified as I can make it. I mean, okay. That's what you want to put in as the answer.
Yeah. And the next one is G of 5.
Okay. What's that?
And we have 5 minus 5 over 5 plus 8. So we get 0 over, that doesn't exist, right?
No.
It's not a real number.
You can have 0 in the numerator. You just cannot have it in the denominator.
Okay.
So 0 over 13 is 0.
Yeah. Alrighty.
What next?
Let me just check. The next one is G of negative 8. So you have so that wouldn't work already. I can already tell that wouldn't work because that's a 0.
Right. Immediately. Undefined.
So does it not exist then?
Undefined. Or
Undefined?
does not exist. Either one pretty much means the same thing. Does not exist. You cannot divide by 0.
Okay.
That's like the #1 rule of all mathematics.
Yeah, true.
It's almost like prevented calculus from being invented. Because calculus is really mired in the concept of dividing not by 0, but by variables that get really, really close to 0. They approach 0. They're infinitesimally small. And that bothered the mathematicians that invented calculus. So much so that Sir Isaac Newton didn't include it in his most famous math book of all time. Even though he had invented calculus 20 years earlier, he didn't trust it. He didn't like this concept of dividing by 0. So he wasn't sure that it was valid. He didn't publish for 20 years, and finally somebody else came along and discovered the other side of calculus and published, and then he decided to publish, and the two of them are credited with the invention of calculus.
Yeah, that's pretty neat, though.
Yes, it is pretty cool. The story behind the discovery of calculus is a very interesting story.
Yeah.
Because it tends to violate the #1 rule of math. But it's okay. You can do that as long as you approach zero. You can't divide by zero, but you can divide by variables that approach zero. Okay, what
Yeah.
else? Is there another one on this?
Yeah, hold on. I'm typing that over right
How
now.
many more are there? One or two for this function?
I think there's one.
Okay.
Yeah, there's one.
What is it?
Okay, it is g of x plus 8.
Okay. What's that?
Okay, so then we're going to have to plug it in, which is, let me see, x. Did I say, sorry, I didn't pronounce right. It was h, not 8, my bad. X plus h, sorry.
Yeah. Just
X plus h.
plug in the x plus h wherever you see x.
Minus 5.
Uh-huh.
Okay, so we get x plus h minus 5, then x plus h plus 8.
And that's actually the answer.
Okay.
There's no simplifying there. I can remove the parentheses so that I have x plus h minus 5. I can't simplify that. And I can't simplify this.
Okay, so would it be...
Simplify that. That's the answer.
Is it not a real number? That's not a real number
No,
then?
it's a real number. It's just go ahead and put that in. H, they're kind of introducing you to calculus. X plus h is a big calculus thing.
Yeah. X plus h minus 5. Oops. No. Give me a second. This takes a while to write with all the little program things.
You have to make sure that you divide that entire numerator by the entire denominator. So you may need parentheses around the numerator.
Yeah, that's what I'm doing. Seeing if this works.
And the denominator. You parentheses.
Yeah, that's correct.
Okay?
Okay. It says, use the graph of the function f to find f of 2, f of 3, and f of 4.
Gonna make you the presenter again.
Okay.
This actually doesn't work too bad once you get used to it. Just takes 4 or 5 mouse clicks to do it. Okay, use the graph. Okay, so we're looking at the graph. Tell me what f of 2 is.
F of 2? Okay, so...
In other words, when x is 2, what is the value of y? That's what they're asking.
Oh, that would, in this case, the value of y would be...
Negative what?
Okay. Would it be the same number as what's the x's, or would it...
Can you see where my... Oh, no, you're the presenter. That's part of the problem here. Look where x equals 2. See that dot?
Yeah.
Now what's the y value there?
The y value? It's negative 2.
Oh, that's the answer.
Or no, it's negative 2.
Uh-huh. In other words, that's what you do, is you go to the area on the x, and, no, hold on, they're not all negative, remember. In other words, you got to go to the area where x is 3. And
okay, so x is 3 is...
That's 4.
Okay.
That's going to be...
So x of 3.
Yeah. X of 3 equals what y value?
Okay, so that one was negative 2. This is x of 3, right? Or is that not? That's
no.
Okay.
You're correct. You're on the x equal 3 point. What's the y value there?
Is this the y value right here?
No, that's the y value for x equal 2. That's the y value for x equal 3.
So would it be right here?
No, you go to the y-axis. Go up to that dot.
Okay. Yeah.
Now go over and read the y value. Go left.
Okay.
Now, what's that number?
Yeah. That's just -2, isn't it? No, that's not. It's
Positive.
just 2.
Positive 2.
Yeah. Okay. And for 4, that's 4, right?
Uh-huh.
Okay, then the y value, is that the same one?
Uh-huh.
Okay.
Now, is this a function? Go ahead and put that in.
Well, yeah, none of the number are the same,
Well,
except for the -2. But
well,
that's
you had similar y values, but for different x values. That does not violate the function rule. It's when you have multiple y values for the same x value that it's not a function. What we're looking
okay.
at here in this graph, is that a function?
What we're looking at here, well, it goes up accordingly, so they would all be different, wouldn't they?
Well, it does
So,
not pass the vertical line test. The easiest way to tell if something is a function is to try drawing vertical lines across the screen, and do they only cross the y value one time? Well, this doesn't. It crosses it. You can't draw a vertical line through their vertical lines. So, no, this is not a function.
Okay.
Let me read the directions, so hold on a second. Determine whether the graph is that of a function. No. An open dot indicates that the point does not belong. Okay, so no is correct. But
All right, this is the 7th. Find the domain of the function.
okay.
The domain is the y value, right? No.
No, the domain.
No, the domain is x value. X value.
So the question you always have to ask yourself when they're asking about domain is not so much what can x be, as much as what can x not be. Because usually x can be most anything. But there are certain functions where there are values x cannot be. What is the x value where it cannot be here?
The x value is in the right place in the bottom, or is in the on the right side.
What can you not divide by?
0.
What makes the denominator 0? What x value?
The negative x.
No. If x were 7, what would the denominator be?
It'd be a -7.
No.
So that
If
would
for
just.
7, the denominator would be 0.
Well, yeah, that's what I was getting at. I'm just saying
Therefore, x cannot be 7.
Okay.
And that's the only thing it can't be. So, do you know interval notation?
Not really. I
can describe it. I don't need to make myself the presenter. Left paren. You'll understand it once we put it in. Left paren.
Say what?
Left parentheses.
Okay.
I don't think it's in that table. It's probably just your keyboard. Okay.
All right. Type this one.
Minus infinity, comma, 7, parentheses, end parentheses, in union, which is the U.
This one right here?
Uh-huh. With parentheses, left paren.
Do you mean like this parentheses? And then a U?
Well, no. First put the right parentheses and then U. No, you only need one of them. Not two of them. Back it up. Get rid of one of those parentheses. Okay. You may need a space there. I don't know. You probably don't need a space, but put one in. And now put another space after the U and put left paren, 7, comma, infinity. Right paren.
Okay.
Now, let's talk about interval notation. What we're saying here is basically all real numbers except 7. And the way to describe that with interval notation is we always go from negative infinity as our starting spot, and we can go up to 7, but not including 7. And then the
All right.
rest of the interval is we can go from 7 to infinity, but also not including 7. And that's why there's a parenthesis around 7. It's because it cannot be 7. If it could
Okay.
be 7, we'd use a bracket, not a parenthesis. But that's interval notation. Is there anything about that you don't understand? The
I
U
think
really means combined. In other words, we have two intervals. We have from negative infinity to 7, and we have from 7 to positive infinity. So that's two intervals. Sometimes you're going to have 3 intervals or 4 intervals or 1 interval. You don't always have 2. In this case, you have 2. Go ahead and enter that.
Okay. This is the last one.
Okay, well, I'm glad you're the presenter. Let me read.
Yeah.
Let me read it. You don't have a drawing tablet, do you?
No, I don't. Do you mean like on the screen?
Yeah, what I'd really like to do is have you draw the answer to this. However, no, that's okay. I don't think you have one on your computer. Go ahead and write what I tell you. Oh, you can't do that. You see the best way we're going to be able to do
You
this.
can take over again and I can watch it.
Let me take over again and you read. I wish I could do a split screen.
That would be nice. I can take a picture of this and send it to you.
No, that's okay. I'm just looking at the options here. No, I'm going to go ahead and make myself the presenter, and I need you to read me that function. V of whatever it was is equal to what?
Okay, let me read that. I'm trying to get this further. So the function is, in 2005, it took 21.46 currency units to equal the value of 1 currency unit in 1917. All right, and then
Go ahead and read the rest of it.
okay, so 21.46 equals 1 in 1917, and then 1990 it took 14.20 currency units to equal the value of 1 currency unit in 1917.
Okay, and then what's the equation that relates the value?
It says the amount it takes.
So it must be V of t, right?
I think you're right. It's, yeah.
Okay. A lot of times when time is the horizontal axis, then the variable is always going to be t. It's not usually going to be x. And what's V of t equal to?
We have point zero. No, it says 0.4968x plus 14.8715.
So glad they add so many decimals just to simplify the problem.
Yeah.
You understand what I'm saying?
So it'll be easy to simplify.
No, I'm being facetious.
No, yeah, it is super unnecessary.
Understand the problem? Why didn't they make these round numbers? Why do they make us deal with all these decimal spots? It just it confuses people. So they want to know what V of 11 is, right?
Uh-huh.
And T is the number of years since 1917.
T is?
Yes.
Okay.
Say that? What's the last couple sentences say?
Number T is the number of years since 1990. Thus V,
thus
1990. V11.
Okay, since 1990. So what am I going to do to figure out what the answer is?
Plug in 11 to t.
Yeah. Is it x or t? Is it x?
It's x, but it doesn't really matter.
That's fine. I'll make it v of x. Okay, so it's 0.4968 times 11 plus 14.8715. Do that math. What do you get?
Okay, let me use my calculator for this one.
Yeah, that's why they just want to take up more of your time by giving us these
Yeah, it's stupid.
four decimal
Plus.
places. I mean, they could have accomplished the same thing by saying 5x plus 10.
Okay, so what I got was 20.3363.
You probably want to make it to 4 decimal points. Now,
Make it to 4 decimal points? Yeah.
Problem is that there could be round off error here. Do you have a 5th decimal place for that?
No, that's what it perfectly rounded out to.
Okay, then that's the answer.
So, that's the answer? Okay. Let me look.
However, it does bring up a point that I would like to make. If you are told to round your answer to 4 decimal places, then you want your answer to be 5 decimal places and then round it off. Because as far as we know, the 5th decimal might be a 6, which would mean that last 3 should be a 4. So you don't really know, unless you put it at 5 decimal places, whether or not you're presenting the right answer.
Okay, so then the next part of the answer says, or the question, use this function to predict the amount of time it will take in 2013 and in 2022 to equal the value of one currency in 1917.
Okay, so let's figure out, wow. Okay, they've told us what one currency is in 1917. And what's the question say again? Sorry.
It says, use this function to predict the amount of time it will take in 2013 and 2022 to the equal value.
2013 first. What is x in 2013?
What is x in 2013?
Remember, x is the number of years since 1990.
Okay, so if we just take 1990, or like 2013 minus 1990, I guess.
So how many
minus years? 1990. It's 23. So you just plug in 23 for x?
Yep. What does that give you?
So let me use the math for this.
Yeah.
And let me plug it in. So we have
annoying that they give you these decimals, because it just makes you take longer, or just waste time, really. Even if it simulates real life problems better, because real life problems don't have nice whole clean numbers, they have decimal numbers like this.
Yeah, it's true.
So what is it?
I have 26.2979, which is exactly what it is, no rounding.
Okay. And what's the second part of that? The year 20 what?
2022.
2022, which is how many years after 1990?
2022. It's 32.
Okay, so now tell me what V of 32 is.
Okay, so you have point. It's 30.7691.
Okay, and then their last question says, what year will the value be the same as 2146? Correct?
No, it doesn't, not yet, anyways.
What? Okay, I must have misheard you. What was the, is there any more
It
parts to this
says
question?
not yet. I just need to type in what the
Oh,
currency is.
okay, go ahead.
So what is the one for 2013? It's 26 point, what
297.
else? 2979?
26.2979.
Okay. It said that wasn't right.
Said it wasn't right?
Uh-huh. So did I
Give,
do something wrong? Because that should be right. I did exactly what it said.
let me check my count. I don't have my calculator up here. Let me do it this way. So we got 0.4968 times 11, which is equal to 5.4648. So I'm going to add 5.4648 to that number. Let me do that. Plus 14.8715 equals 20.3363. Got the same thing you did. So,
Wait.
problem is we're probably off by 1 year.
Okay.
Again, X is the number of years since 1990.
Yeah, 1990 to that point.
So 1991
let me
would
read
be
it.
what for X?
Hold on, I'm just reading it to make sure. It says, yeah, determine the X value that is the number of years from 1990 to 2013. So that'd just be 23 years, wouldn't it?
Okay,
So
yeah.
that's
Yes, it is. In other words, to make sure that sometimes when you're trying to determine the number of years between 2 years, it's easy to be off by 1. So the way to figure it out is, what if the year was 1991? What would X be?
1991, it'd just
1
be,
year, and we got it by just subtracting the two numbers, right?
mm-hmm.
So 2013, we subtract the two numbers and we get 23. So this part should be correct. Which answer
Maybe it
was
wants to
not
round. I'm
correct?
trying to see.
Was it the V of 11
It was
that
that
wasn't
one,
correct, or was it the V of 23?
V of 23.
The V of 11 was correct?
Yeah, that was correct.
Let me do the math on the 23. 0.4968 times 23 equals that, plus
Oh, it says
14.
round to 2 decimal places.
That's the
So would
problem
it be,
with problems, is that they always throw in the kicker. So
would it be 30? Or would it be 26.30
yes,
or
or
0.3?
0.30, either one. And you know
Okay.
what? I would put in 26.30.
Okay, yeah, that was
If you
correct.
put in
And then,
0.3, you could have been rounding to 1 decimal point. So by adding that extra 0, it tells anybody that you've rounded it to at least 2 decimal points.
mm-hmm.
Is that correct?
Yeah, that was correct.
Okay, and then the last one is probably going to be 30.77.
Okay. Let's say so then the next one,
Uh-huh.
we have the last question to this is, when will it take approximately 40 currency units to equal the value of one currency in 1917?
Okay.
And so if we're
That's
already at,
asking for X, right?
yeah, that would be X.
Okay. So here, I'm going
So
to
if we're
write
already
really
at,
small. Let me first of all get rid of my GoToMeeting screen. I'm going to write over here in the lower right. Okay. So
okay,
they want to know when V of X is 21.46, because that's what it was worth in 1917. So all we have to do is solve that equation with x being the unknown. In other words, once we solve for x, we'll know what the answer is. That's an equation with only one variable. Solve that for x.
Okay.
Now,
Are you sure that's it? Because that sounds a little...
2 decimals, this is rounded to 4. So I would put in 0.4600.
0.4600?
Well, first of all, you got to subtract 14.8715 from both sides.
Okay, well now, is this the right equation? Because I feel like it's a little weird for that. I could be wrong though. Do you want me to read it again?
No, I think I have a good idea. They're basically saying, when is v of x equal to 21.46? Notice that v of 11 was 20, v of 23 was 26, v of 32 was 30. Somewhere between 11 and 23, this thing's probably going to be equal to 21.46.
It's asking when it takes 40 units to equal 1. It says...
Let me make you the presenter. Let me read that.
Okay, show my screen.
When will it take approximately 40 currency units to equal the value of 1 currency unit in 1917? Let me read the original problem. Let me just make sure I understand it. In 2005, it took 21.4 currency units to equal 1 currency unit in 1917. In 1990, it took that many. The amount it takes to equal the value of 1 currency can be estimated by V given by V of x, where x is the number of years since 1990. Thus, V of 11 gives the amount it took in 2001 to equal 1 currency unit. Okay, this number is going up, so we need to set it equal to 40, our equation.
Okay.
Wants to know when it's going to be equal to 40 currency units. Well, in 2013, it was equal to 26.3 currency units. In 2022, it's equal to 30.77 currency units. So I'm going to make myself the presenter again.
Okay.
Hold on a second. What happened? I lost it. Hold on. I guess I just click on me. No, make presenter. I wasn't seeing that last time. So the equation we're going to solve is where instead of equal to that, we're going to equal 40.
Okay.
In other words, that was how many currency units it was in 1917. But we want it to be 40 currency units, not 21.46. So 40 equals that equation. There's our equation.
Okay.
And solve that.
All right. So would we have to subtract 14.8715?
And then take that answer and divide it by 0.4968.
Minus 8715. It's 14.8715. Yeah, okay. So we get 25 divided by 0.4968.
Not
And then
X.
we get,
Just 0.4968.
okay.
What do you get? 50 what?
Just a minute, I think I typed it in wrong. I accidentally deleted it too, so doing it one more time.
Okay. I know it's at least 50 something.
25 divided by 0.4968. And we get 50.850 units is the number that keeps going. So
Okay.
rounded to
What
the,
year is that?
what year is that? That would, hold on.
From 1990. If you add 50.85 years, where is it?
From 1990? Okay.
Uh-huh.
It's like, hold on.
Is it going to be 2040 or 2041?
I think it'd be 2041 if you round.
No, you don't want to round. Look at the question. What year will it happen?
2040.
2040. 8.85 hundredths of the year, which would be like November of 2040.
Okay, so it'd be 2040 then.
Yes. In other words, in this case, you always are going to round down because it says, what year does it happen? It happens in 2040. It doesn't happen in 2041.
Alrighty. I'm looking. Okay, cool.
Okay.
That was correct.
What else?
Well, that's like,
4 minutes.
that's all I got for right now, actually.
That's fine. We're just about done anyway. So, any other questions?
I think we're good. You helped me out a lot, so.
Okay. And then let's see.
Alright.
Just check my schedule here. Verify when your next session is. I got you for 2 sessions tomorrow. Did you intend to do that?
Yeah, is that alright with you?
Sure.
Yeah,
At
okay,
11 for an hour and at 3 for an hour.
cool. Mm-hmm.
I'll talk to you at 11 tomorrow morning.
Okay, cool. Thank you. I appreciate your help.
All right, Mary.